Okay, so when we're asking you about domain, we're asking you about the possible x values that you can plug into a function. Okay, because the range depends on whatever you're plugging it in. Every function has its own range depending on what you plug into it. So x is the domains, and we're trying to see if any of these functions have restrictions. Okay, I like to think of domain restrictions like you think of food allergies. Some people have food allergies and they can't eat those type of foods, okay? Like a gluten intolerance. People that have gluten intolerances don't want to eat food with gluten, or their bellies get upset and they get all bloated and it's uncomfortable. Okay? So we're trying to figure out which mathematical numbers are going to make this function bloated and uncomfortable. Okay? And you have to avoid those. Right? If I have an allergy to shellfish, right, something from the sea, something that lives in a shell like escargot, or crabs, and I eat crabs and my throat swells up and I die, right? That's not what I want. I don't want to die from eating food. But for the most part, functions have all real numbers. Like all linear functions have no domain restrictions, right? You can plug any x you want to into a linear function and you're always going to get out a y. Okay, same thing for all polynomials. Those would be like quadratics and cubics and fourth degrees and fifth degrees and sixth degrees, right? No problem with any of those kind of things. Okay, exponentials also have no domain restrictions. Let's look over there. Cube root functions don't have any domain restrictions. So most of them are pretty good as far as not having any food allergies, as is the general population. Normally is okay with eating anything they want whenever they want. Okay, but there are some that do, like this one. Other functions are not so lucky. So as you see these two examples, f and g, these are both examples of rational functions. They have a variable in their denominator and they are written as a fraction. Just like rational numbers can be written as fractions, rational functions are written as fractions. Okay, does anybody know what the restriction is on all rational functions? Excellent. I will tell you then. The restriction is your denominator cannot be equal to 0. We cannot have a 0 in the denominator because that is an undefined term. You can't divide something into 0 parts. Right? That's like part of the conservation of matter for the universe. Denominator cannot be equal to 0. So what do we do to figure out what numbers to restrict? Well, you take whatever your equation is in your denominator, and you set it not equal to 0, and then you solve that equation. And whatever those solutions are, those are the numbers that you are not allowed to use. Right? Those are your mathematical allergies that will make your function unusable, right? Undefined. And it's good to have definitions for everything. So if we're looking at f, right? F says x minus 5 over x plus 2. Okay, what is our procedure in order to figure out what our domain restriction is going to be? Which of those two equations is your denominator? The x plus 2. So you take your x plus 2 only. We're not concerned about the x minus 5. And you set it not equal to 0. And then we solve this equation. Okay, so when we solve this equation, what is the number that x cannot be? Negative 2, right? We subtract 2 from both sides. So x cannot be negative 2. So there's lots of ways that we can write this as an interval. If you really want to write it as an interval, I would not suggest it. But it looks like this. Everything from infinity to negative 2. Okay, with parentheses. And then combine that with everything from negative 2 to infinity. Okay, it's kind of a redundant way to write this one. Right, that means everything except for negative 2. It's much easier to use it as a set builder, Okay, any real number that we want as long as x is not negative 2. Any number except for negative 2 will be good. So the other function that we're going to be concerned about finding the domain restrictions for are these special square root functions. Okay, and only square roots. I guess any type of an even root. Only even roots have domain restrictions. Okay, because squaring things makes them positive, but you can't take the root. Oh, that's the restriction. Haha. The restriction is you cannot take the square root of a negative. Okay, so we need to make sure that our radicand, here we go, can't take the root of a negative. So we have to make sure that the numbers, or rather the number that we're taking the root of, must be either 0 or positive. Okay, and we call all those numbers non-negatives, or whole numbers. It has to be I guess it can be decimals too, huh? It just has to be a non-negative number. So the procedure, what do we do in order to figure out which ones to throw away? You take your radicand, which is all the stuff underneath the radical, and you make sure it's greater than or equal to 0. Okay, so that's the procedure that we're going to do anytime you see a radical function. Okay, a square root or a fourth root. For cube roots have all real domains. You can take the third root of positives and negatives, but you can't take the square root. So let's look at some examples. Here we have f, the root of 2x minus 6. Okay, so what is the radicand for that function? 2x minus 6, right? This stuff right here. This is the radicand. 2x minus 6. So we take our 2x minus 6 and we set it greater than or equal to 0. Okay, and then we solve. Right? This is a two-step equation. We add the 6 to both sides. And then when we divide by 2, we get x has to be greater than or equal to 3. Okay, so there's an inequality, right? That's all good. We could make it into a set notation, okay, by saying we're talking about all real numbers and putting some braces on there. My 7th period class Googled it, and those funny mustaches are called braces. Okay, looked it up. So that's what it would look like as a set builder notation, or because it's an inequality, right, this is pretty easy to do as just an interval. So everything greater than or equal to 3 is bracket 3 comma infinity, and then another parenthesis. Okay, so depending on what your paper asks you to do, what it wants you to write it as, do one or the other. Okay, whichever one is your favorite if you're not told what to do. Okay, so take a second and do h. Find the restriction on h. And this would be the solution for h of x. X is less than or equal to positive 1/2 would be the domain restrictions. So we can't plug in anything bigger than 1/2 into that function, or you're going to be taking the square root of a negative number. Okay, now our last example here combines both of our two rules. Right? Not only is it a square root function, but it's also in the denominator. So we have to take both of our restrictions and apply them equally. Okay, so what is the restriction for a radical? For a radical, right, a square root, it has to be greater than or equal to 0. Right, because first of all, we have a square root. But then where is the square root? It's in the denominator. Okay, and what does the rational restriction say? It can't be equal to 0. So we have to adjust this a little bit by saying it can only be greater than. If we have a radical in the denominator, then that x has to be strictly greater than 0. Okay, not equal to anymore, just greater than. Okay, so when we set up our algebra, 2x plus 10 must be greater than 0. Strictly greater than. Okay, so the algebra says subtract the 10, divide by 2, and we get x has to be greater than -5. So as an interval from -5 to infinity. Okay, so not all functions have restrictions, just like most people don't have allergies to food. Okay, but some of them do. And when they do, you have to figure out what numbers or what allergies you cannot plug into your value or into your function. Ones that make the denominator 0 for rationals, and ones that make the radical negative for square root functions.